Alright guys, welcome back to our unit on bonding and molecular structure. We are going into day 4 on our C.3.4. Alright, this is our third form to learn for binary nomenclature. We're doing binary-ionic-transition metal nomenclature. This is what I call bit metal nomenclature in the notes. Classically, however, it is referred to as stock convention. I think this is going to be one of the more difficult areas to learn, but never fear, you are always going to have availability to your notes, yeah, there's nothing to get stressed out about or anxious about because you will have these guided notes and plenty of time. We're going to be working everything out together like we normally do, okay? So the bit metal nomenclature on the notes. Again, classically it's called stock convention. So the transition metals in columns 3 to 12 often have multiple valences. If you look at your periodic table, the transition metals are that they're the middle area that forms kind of like a box. You'll see that they're color-coded as transition metals. And columns 3 to 12 are what we're looking at. Okay, so one starts kind of closer to the right-hand side, and then it wraps back around to the left-hand side. These are 3B to 12B, okay? Groups 3B to 12B. You must memorize both charges that go along with the symbol. It's the only way you're going to make it. Fortunately for you, you always have access to your notes, right? So keep up with your notes. Make sure that you're looking at your notebooks. If you're missing pages, let me know. Look in the bottom right-hand side. All of your pages are numbered for this unit. Roman numerals are used when identifying which ion is being used. So for copper 1, we have Cu, our chemical symbol, okay, and then we have a +1 at the top right. Copper 2. For copper 2, we have a Cu, our chemical symbol, and we have a +2 as our superscript. Alright, we're going to pause the video and do some transition metal charge symbol practice. These two are in red because they're going to be a little bit tricky. Okay, binary-ionic-transition metal nomenclature, stock convention. Multiple valence ions. For ions that contain cations that have multiple valences, Roman numerals must be used to indicate which version of the ion it is. For example, iron 2 oxide. Now you don't see a 2 subscript here, do you? Remember, this occurs when there is a -2 charge and a +2 charge, okay? Because we know that iron 2 is going to necessarily have a 2+. As a transition metal, it's going to have a positive charge, right? And oxygen has a 2 negative charge, okay? So those are going to balance out. That's why it can get kind of tricky. Iron 2 oxide. Now, what's really happening here in iron 3 oxide, we do flip them, okay? The reason they're noted is because they are not the same number. This is a +2 and a -2. This is a +3 and a -2. So that's why it gets really tricky, okay? We learned a little bit about this before when we were talking about balancing and not balancing. What is really happening right here is it's going to be a +3 times 2. That means there's +6. We have a -2 times 3. That means there's a -6. So that gives us an overall neutral charge, okay, for this compound. But when you're looking for trying to name transition metals, remember to look to the right-hand side, okay? We can't say mono iron. It's a transition metal, for one, okay? We always end in "ide," okay, but we're using Roman numerals instead. So this is iron 3. We can't say iron 1. Why can't we say iron 1? Well, we can't say iron 1 because oxygen has a -2 charge to it. This is neutral. So that means that there's no 2 anywhere. Okay? So really pay attention to what's in your valence, guys. The key to solving these really is to look at whatever is your non-metal. Okay? If you look at your non-metal and you look at the charge of that, that will help you figure out what is the number on the preceding transition metal if there is no subscript. Okay? So this has a -2 charge. If you look at your periodic table, the nonmetal has a -2 charge. And if you have a nonmetal with a -2 charge that's attached to, and it has nothing to the right of it, then you know that the preceding is going to have, the preceding transition metal is going to have a +2 charge because it balances. So neutrals don't necessarily have flipped subscripts all the time. Okay? So naming binary compounds containing a transition metal. We have iron 3 oxide. Now it looks like you would say iron 2, but remember, when you are working with anything in the transition metals, you're going to go look at the furthest number to your right that's connected to it. Okay, in binary, you're going to look to the furthest right subscript, iron 3 oxide. You really kind of skip this over, but it's necessary to write it so that you have a neutral compound. So make sure that you're doing your multiplication right, okay? 2 times 3, positive 3 times 2 is positive 6. -2 times 3 is -6. We want them to balance, okay? Iron 3 oxide. Zinc 2 chloride. Notice these are all Roman numerals. If you guys need a Roman numeral review, we'll discuss that at the end of class. And I can make it as an additional learning. I'll put an additional learning guide on, and we'll do some more in-class work. But you should know up through 10 by now. And if you don't, then we will definitely problem solve for that. Okay? Again, you're going to continue to have access to your notes, so please don't get anxious about this. I want this class to be fun. I want you to enjoy your time. And if there's anything that makes you uneasy, please see me during my office hours so that I can work with you. Okay? So we have zinc 2 chloride. Remember, go to the furthest right subscript. Uh-oh. Here we have no subscripts. What does that mean? Well, remember the first step when we have no subscripts is to find out what our nonmetal's charge is. Chlorine has a -1 charge. That necessarily means this must have a +1 charge. So that means silver 1 chloride. Okay? Now, if it wasn't a Cl here and it was something else that was a nonmetal and that was not a -1, it could be a different, it could have a different Roman numeral associated with it, even if it was no subscript listed. So you have to really be careful here, folks. The only time that that's going to happen is when there are no subscripts. If there are subscripts listed, you have your answer. If there are no subscripts listed, you need to do some troubleshooting by looking at the right-hand side, okay, the right-hand element, which is going to be, or atom, which is going to be the non-metal, okay? We have copper 2 phosphide, okay? So we have copper 2 phosphide. These are self-explanatory. Wait a minute. Here we have a rule exception. We have a couple rule exceptions. This is where it gets tricky. This is why I said the stock convention is super hard. It's a challenge. It's one thing that I struggled with as a young chemist. And if I'm not super on my P's and Q's, I may mess it up myself. So it's just something you really need to be aware of. See, this has a subscript of 2, but it's lead 4. Why is that? Well, it's because when you're balancing the electrons, you necessarily have to have 2 sulfurs, okay? Because sulfur, let's see here, CNOFPSCl, okay? Sulfur has a -2 charge to it. So -2 times 2 is -4. Does that make sense? And lead, because lead has a +4 charge here, +4 and -4 equals 0, right? So that's a neutral molecule, neutral compound. I'm sorry. So these are really tricky. You just have to really pay attention. Make sure that when you are going to your periodic table, even if you think you know, well, oxygen has a -2 charge, go check. Go check. Look at the one on the right-hand side. Pull out your periodic table. How many positives, how many negatives electrons are on that valence shell? If it's not, okay, so oxygen 2, chlorine, we know that's -1, right? Or -2, I'm sorry. And then we know that, so it's really complicated. You have to look at it. Magnesium 4 oxide. Well, remember that we learned that oxygen has a -2 charge, okay? So -2 times 2 is -4. Well, that necessarily means that manganese, I'm sorry, I read that wrong. Manganese necessarily then has to have a +4 charge to balance it out. These are all neutrally charged. There's no superscripts on any of these. Those are behind the lines, hidden within these subscripts, okay? It's impossible to note everything all the time. You don't want to write everything all the time either. So it's really important that you understand this chemistry grammar for stock convention. All right, we're going to pause the video here, and we're going to do this nomenclature and formulae practice. Instead of saying formulas, formulae is a way of saying more than one formula. It's Latin. You guys should learn a little bit of Latin in this class, as I'm teaching you through a modern classical practice. All right, guys, time to enjoy yourself a little bit and do some stock convention spaceman. It's kind of like hangman, but it's the friendly version. We're going to be doing it on the PowerPoint. You guys can have teams, and you can earn points for your team. And also, after all of that is done, I will have, I know I said I won't generally have take-home homework, so we've got a worksheet that we will be filling out together next class period, okay? And that will complete our lesson for this day, okay?